Hello, Alyssa. This is Miss Tracy. So I'm going to show you how to do this. This is not super complicated. It's all about shifting decimals, and then it's just subtraction from there. So we've got this number that we need to write as a fraction from lesson 104, 105, right? So what we're going to do is we're going to say that this number is n. We're going to treat it like a variable, right? This is n. And we're going to look at the number of places that repeat. There's 2 places that repeat, so that's how many zeros I'm going to put on behind this 1. So 2 places, 2 zeros. Now I'm going to say 100 times n is equal to, move this decimal place 2 places. So it's 1.524, and we're going to write 24 one more time and put that over. Okay, because we shifted everything 2 places over, we need to do that. Now I'm going to take the number just like it is. N is equal to 0.01524 repeating. And we know that that's 1n, right? Now, these are stacked on top of each other. We're going to use elimination to solve. So I'm going to subtract. 100 minus 1 is 99. And then I just need to subtract this. Now, if these are repeating and they are directly over one another, they're going to repeat forever and forever. 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4. And if I subtract 4 minus 4, I get 0. And 2 minus 2, I get 0. And you can imagine that happening all the way down the line of this forever repeating pattern. If you have, for instance, 2, 4, 2, 4, 2, 4, 2, 4 over 2, 4, 2, 4, 2, 4, 2, 4. And you're subtracting 0, 0, 0, 0, 0, 0, 0, 0. So it all goes away, right? It all goes away. So that's what we're doing when we are multiplying by a power of 10 that is equal to the number of places we have here. So 2 places, 2 zeros, that's 10 to the second power because we have 2 places, right? 10 to the second power equals 100. Because we have 2 places, that's that 2 right there. That's what you're doing, okay? Because of that, it lines up perfectly so that we can do all of this subtraction. We can subtract repeating 24 minus repeating 24, and that gets canceled, so now that's a 0. Now we can just subtract the rest of this. It's like they cancel each other out, right? So we're subtracting this also. We're subtracting everything. So I'm just going to pull out my calculator right over here. And I'm going to say 1.524 minus 0.015. I get 1.509. So 1.5090. Now, I have 99. And 99 times some number is equal to this. So I'm going to divide both sides by 99. Now, I have a decimal and a fraction. Can't do that. Can't do a decimal and a fraction, right? We know that. We can't do that. That's not right. Let me get rid of that 0. So what we're going to do is we're going to multiply this number times 1, 2, 3, the power of 10 to the third place, because we got 3 decimal places, which equals 3 zeros. So 1,000. So times 1,000 on the top. Now these cancel. We've already done this. N is equal to 1,509. And then we have to do the same thing on the bottom because we're multiplying the top and the bottom times 1,000. So that would be 99,000 on the bottom. So 1,509 on the top and 99,000 on the bottom. Now, if we can reduce this, we should check and see if we can reduce, right? So let's see if we can reduce 1,509. Let's divide that by 3. Okay, 503. Can we divide, so that's equal to 503 If I divide this by 3, so if I divide it by 3, can I divide by 3 on the bottom and get something? I think I can. I think it's 33,000. 99, 1, 2, 3, divided by 3, 33,000. Cool beans. So that's 33,000. Can I do it again? I know I can divide this and get 11,000, so let's try and see if we can divide this on the top, divided by 3. Nope, it won't divide. So this is as small as we can go. This is our answer. 503 over 33,000. That's as good as we can do. That's where we are. So that would be the first problem. So now we're just going to do this for the second problem. All right, and the second problem, let me clear all of this out of the way. Actually, I'm just gonna roll it. Just gonna scroll it. The second problem, let me get that up here. All right, so on the previous one, you don't have to reduce it, by the way. I just looked at the answer, and the answer is this. You don't have to actually reduce this fraction. I was going a step too far. This is the answer that it's looking for, and it wants a comma right here when you type it in. All right, so on this one, again, we set that equal to n, whatever n is, or you could use x or t or s, it doesn't matter. So we're going to say, okay, there's 2 places here. So 10 to the second power is 100. This is what we're going to multiply. So 100 times n is equal to, shifting it 2 spaces, 1.432, and we write it again, 32, because it repeats, put the line over it. And then the n, the original 1n, is equal to 0.01432 with the repeat line over it. Subtracting everything, because we can, because we're using the stacking method, the elimination method, we just multiplied everything here by -1. That's what we did. That was our step. We multiplied everything here by -1 so we could subtract. So we did that to this side, we did to this side. So that's why we can do that. That's why we can get away with that. Okay, so now if you want to look at it like this, we took this whole thing and said -1 times this, and we put it right here. Okay, now we're going to subtract 100 minus 1 is 99n. And then this cancels this because they line up perfectly. Now all we have to do is actually do the math. 1.432 minus 0.014. 1.418. So 1.418. Now we divide everything by 99. But this would cancel. This has got 3 spaces. So we're going to multiply that by 10 to the third power, which is another way of writing. Oh, come on. 1, 2, 3. Whatever power you have, that's how many zeros you have. That's pretty straightforward. So top and bottom, which gives us 1418 over 99,000, which is probably the answer. Let me check. Yep, and it's got the comma right there also. So that would be your answer. That is all you have to do these problems, right? You look and see, let me get rid of this, how many spaces are repeating, and that's the number you use here to multiply that number by. And what that does is it makes the repeating part line up on top of itself so that it cancels each other out. You multiply this whole thing by -1 so that you can subtract it, and you just use the same methodology that we use for elimination to solve and get a fraction, right? We're just eliminating this from both sides. And then we get rid of that decimal because we know we can't have a decimal in a fraction. So that's our final result. Okay? The number of zeros here is just the number of places you have behind the decimal. That's all you're doing. Do it to the top and the bottom to keep it the same, to keep it balanced and true, and then that's your answer. All right, that was 104, 105. Let's look at 110, 111. All right, so this is 110 through 111. There's another one of these little problems. It's the exact same thing we did before. We set that equal to n. There's our n. We've got 2 places, so that's 10 squared, which equals 100. So that's what we're going to multiply both sides by. So that gives us 100 times n is equal to 100 times this just moves the decimal place, right? So 121, 3.3, and then 13 repeating. And then this would be, we multiply that by -1. So then that gives us -1n is equal to -1.213. We're going to use elimination. That cancels these two. And then we subtract. We get 121.3 minus 1.2. We get 99n is equal to 120.1. Divide both sides by 99. N is equal to 120 or 1,201. There's one decimal place, so we're just going to multiply this by 10 over 10. So that's going to be over 990. 1201 over 990. Okie dokie. So same steps every single time. Every single time. It's not hard. However many places are being repeated, that's the power you use, and that's what you're going to multiply to shift that number so that these line up exactly. And then that allows you to cancel them through subtraction. And then we subtract the rest of the real numbers. And then we're able to divide to put it in fraction form. And then we multiply to get rid of the decimal in the numerator. And then we're done. Okay? Easy peasy. All right, let's do the other one from 111. All right, this one was kind of complex, so I took a screenshot. So one of the things that we know about the I, the imaginary complex number, is that it is, I is, of course, equal to the square root of -1. So when we have 2 of these, it's equal to -1 itself, right? So we can get rid of multiple exponents and reduce this down. So this would be 2 times -1 I, because we have that third one right there hanging out. And then I can take out of here, I've got -1 times 3, and then -1 and 3, right? And these are times each other. Square root of -3 times square root of -3. Well, the square root of -1 times square root of -1, that's going to be -1. And square root of 3 times square root of 3 is 3. So that's the numerator solved. Down here, we've got 4 minus 3, and I squared is -1. So when we reduce this, we've got -3 times -1, so it's going to be 4 plus 3, because that becomes a positive. Now we can resolve this. This is going to be a -2i, and negative times a negative, that's going to be a positive 3, because positive 1 times 3 is positive 3, and this is going to be 7. Now we can never have I as that first term. That's just not standard format, and we can't have them together in the same one, so or the same fraction. So we have to rewrite this appropriately. So it'll be positive 3 over 7 minus 2 over 7i. I believe that's the way we have it over here. Yes, that's exactly right. That would be your answer. All right, so let's do the last one. All right, so we're going to take 40 inches per second and turn that into meters per hour. So we start by just saying just that, 40 inches per 1 second. And we're going to multiply. First, we're going to take care of the unit of measure up here, the length unit of measure. So this is our distance. So we're going to want to go to meters. So we need to go to centimeters from inches. So that would be 2.54 centimeters, same as 1 inch. Those cancel. Centimeters to meters. There's 100 centimeters in 1 meter. So 1 meter is the same as 100 centimeters. Those cancel. Now we have meters, which is what we were going for. Now we have to go from seconds to hours. So we're going to multiply. We know that there are 60 seconds in 1 minute. All right, so notice how I put the seconds on the top, because you got to cancel one on top, one on bottom. So we flip it. What we want to cancel, we put on top instead of on the bottom, whenever where we start is on the bottom. So now I want to get rid of minutes. I want to go to hours. So I'm going to do the same thing. 60 minutes is 1 hour. So minutes cancels. Now I just write it all out. 40 times 2.54 times 60 squared, because it's 60 times 60, all over 100. And that is going to be meters per hour. And let me see how they wrote that. All right, so it's going to be, hang on. Yeah, so meters per hour is actually written with the number in the same fraction. So you need to put meters here and hour here. And you're not going to hit the space bar. You're just going to write it just like that. That's the answer for that. All right, if you have any other questions, please feel free to holler. Once the school year is over, I typically check Jupiter about once a week. So if there are things that you're still working on that you want to finish, you can. I'm just not going to check it as often. So do ask the question, and I'll check it, like I said, at least once a week, maybe twice, just depending on what's going on. And, if I'm on vacation, I'll let you know. But you can work through and you can master the pods as you need to if you want to raise your grade. If you're happy with your grade, you don't have to work past the end of the school year, but it's up to your mom. Whatever your mom says. If your mom knows that we're going to leave these pods open for you to go back and practice and keep your skills up, she's probably going to want you to do that. But it's not a bad idea to go in and maybe, 3 or 4 weeks into the summer, open up the final exam and just see if you can still work the problems, right? Or open up one of those last lessons, see if you can still work the problems. The quizzes and the exams are a better judge because it covers a wide range of problem types. So just open it up and see if you can work one of those, still work the problems. If you can still work the problems, that'll keep your skills fresh. And then you can go on, when you get ready to take the ACT, you won't have to relearn everything, right? This is for your own benefit. So just, keep your skills fresh, and you'll do well. All right, that is all I have. I will see you tomorrow.